Assalamualaikum and hi everyone. In this video, we will like to discuss about application of differentiation. So, let's begin. So, for introduction, in calculus, differentiation is one of the two important concepts apart from integration. Differentiation is a method of finding the derivative of a function. Differentiation is a process in maths where we find the instantaneous rate of change in function based one of its variables. The most common example is the rate change of displacement with respect to time called velocity.
Have you ever thought what is differentiation? In mathematics, differentiation is a process to find derivative of a function or the rate of change. Differentiation from the first principle is by taking the limit, but they are standard derivative. In conjunction with rules such as the product rule, the chain rule, and the quotient rule. Related rates. A related rates problem is a problem in which we know one of the rate of change at a given instant.
So, hi everyone. Today I want to explain this question to you. This question about the radius of a spherical balloon that filled with air increases at a rate of 0.5 cm per second. Find the rate of the change of its volume when the radius is 4 cm.
So, there are 4 steps or process to solve this problem. First, we must understand the problem. Second, planning the strategy. Third, implementing the strategy. And fourth, check, reflect and interpret.
So we need to understand the problem first. Then at this question, let R and V become the radius and the volume of the balloon respectively at t, which is time. After that, we need to form an equation that relating to volume to the radius of the balloon. The equation that we formed just now need to use the chain rule to relate the rate of change of volume to the rate of change of the radius of the balloon. So, as we know that formula volume for sphere is 4/3 pi r cubic, we need to differentiate the formula and it will become 4 pi r squared. So, our equation for this calculation is dv over dt equal to dv over dr multiplied with dr over dt. So, we know that r is equal 4 and dr over dt is equal to 0.5. Then, we just need to put the value in this question. So, dv over dt equal to 4 pi r squared, which is the value of r. We already changed it to the 4 multiplied with dr over dt, which is 0.5. Then just calculate like usually and we will get the answer is 100.5 cm cubic per second. That is how we will get the rate of change of the volume of the balloon.
For the next question, a 5-meter ladder is resting against the wall. The bottom is initially 3 meters away from the wall and is being pulled away from the wall at a rate of 0.0 meter per second. How fast is the top of the ladder sliding down when the bottom of the ladder is 4 meters away from the wall? So we can sketch like the shown figure. So we have known here that df over dt is equal to 0.05 meter per second based on the question. So we need to find dw over dt when f is equal to 4 meter. So we will use dw over dt equal to dw over df times df over dt. So in this case, we will use theorem Pythagoras. First thing first, we need to substitute the value given in the question, which is the length of the ladder 5 meter. So the formula will be w squared plus f squared equal to 5 squared. So we want to find w. The value of w is square root of 25 minus f squared. So next we are going to differentiate the value of the w. So it will be dw over df. dw over df is equal to negative f over square root 25 minus f squared. So next we are going to substitute the value that we have found into the formula of dw over dt equal to dw over df times df over dt. So after we have substituted the value, we will get dw over dt, which is negative 0.05f over square root of 25 minus f squared. So we will substitute f equal to 4 in this equation. So we will get negative 1 over 15 meter per second for how fast the top of the ladder sliding down when the bottom of the ladder is 4 meters away from the wall.
So, for conclusion in this video, we can conclude that the application of differentiation can be used to solve any kind of problem in our life, solve problems related to value of volume, define a value of a volume, and last but not least, apply the Pythagoras theorem formula when solving any problem that involve finding an unknown side of triangle. That's all from us. I hope you guys enjoy watching this video. Thank you for watching. Bye.